We're going to have to get you guys some caffeine or something. Who knows? Get you to talk more. All right. So I can't remember where we left off, but I think what I'd like to do is kind of go over the did we talk about the 5-number summary last time? We did. Did we talk about the Stdev and leaf or the box and whisker plots?
I think very briefly.
Briefly. Okay, let's review that again. Okay, so I'm going to just review this really quickly. So 5-number summary consists of your minimum, quartile 1, the median, quartile 3, and the maximum. Median's the 50th percentile. Quartile 1 is the 25th percentile. Quartile 3 is the 75th percentile. You can think of these two quartiles as the median of the top half and the bottom half of your data. The interquartile range is Q3 minus Q1. We're going to create some fences. When we're figuring out outliers, we have to decide what is the fence. So we're going to use the interquartile range to find the outliers. The formula is quartile 1 minus 1.5 times the interquartile range for the lower fence, and the upper fence is Q3 plus 1.5 times the interquartile range. So if the value is outside that range, it's an outlier. So I don't think we did this spreadsheet here. Let me pull up this spreadsheet here. So let's go over this. We're going to actually create a box and whisker plot. Oh, maybe we could do it with that too. All right. So I've got a random sample of 18 collision coverage claims. And I want to create a box and whisker diagram. And we're going to look for outliers. Now, I might be a little bit different than the book on this, so I'm gonna be a little. I want you to make sure that you're following my procedure here. So the first thing we need to do is sort the data, which is really easy in Excel, but it's a lot harder in on pencil and paper. Okay. Okay, so I've got 18. Yeah, I've got 18 coverage points. So we've got the minimum, Q1, the median. I can never put on median. I don't know why. Q3 and the maximum. And so let's see here. Who can help me? How about Clark? Can you help me find the minimum and the maximum?
Yeah, the minimum would be 180. Okay. And the maximum would be 21,147.
Okay. And then since those were easy, can you help me find the median?
So you do 20, it'd be number 10.
Which be careful because you can't really trust these. We've got 18 of these, right? 18 plus 1 is 19.
Okay, 18, yeah. Yeah, okay, so 19 divided by 2. 19
divided by 2 is 9.5, right? So yes. 1, 2, 3, 4, 5, 6, 7, 8, 9.5. So we're going to use both of those numbers, right? And so how do I find my median?
You would divide, you would add them and then divide them by 2, right?
We're going to add them together and divide by 2. Okay. So the median is 1802. Okay. All right. So since Clark did that, Cody Lynn, can you help me find quartile 1?
Yes, I can. I started talking before I unmuted myself. So you take, I'm trying to think of how, that's 9 numbers from like 2 to 10, right?
We want to make this an odd number. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay.
And then we take the 5th number, right?
So 9 plus 1 is 10. 10 divided by 2 is 5. So 1, 2, 3, 4, 5. So that would, so 735 is your quartile 1. And then I'll let Tori, Tori looks like, do you guys remember that show Home Improvement where you can never see the guy's face? You can't see Tori's mouth. She's like the opposite of the fence. Okay?
Hello.
Plus she's got a mask on. Good
So
job.
you
So how
do
do you find quartile 3?
you do the same thing that you did for quartile 1, and so it's 9, so you add 1 and then divide it by 2, so that'd be 5.
Okay,
And so that
we're
would
counting
be
5 from the 1953, right?
on row 15, so that'd be 4,668.
So 1, 2, 3, 4, 5. Okay, 4668. Okay. Perfect. You guys are around the ball. Okay, the interquartile range. Let's say, Zach, can you tell me what the interquartile range is?
I think we're all gonna make that mistake of muted microphones. Let me pull up my notes on that.
You'll memorize this both for the quiz and the test, though, right?
Yes.
Okay, good.
Remind me the formula for that. I don't think I'll get to that
Oh,
fast
you don't
enough.
remember that? So the interquartile range was Q3 minus Q1.
Okay. So the interquartile range would be uh 3,933.
How did you
I
get that?
believe. I subtracted Q3 from Q1.
So 4668 minus
735.
735 works out to be 3933. Okay, well done. Okay. All right, now we need to do the lower and the upper fences. Let's see if, Mallory, do you remember how to find the fences?
So for the lower fence, it's going to be the quartile 1, which is 735.
Okay.
Subtract 1.5 times 3933.
Okay. So we got a negative number. That's interesting. Okay. And then for the upper fence, can you tell me what that is, Ellie? Ellie switched from her phone to her computer, I can tell.
No, my computer is still like having issues, so I'm on my phone today again.
Oh,
which
you
is,
are?
like,
Because before you were like a
terrible.
tiny little thing and now it looks like your computer. Anyway. Upper fence is?
So that's Q3 plus 1.5 times the interquartile range.
Okay,
And was
Q3
what was
is?
Q3? Was that 4468?
Yeah, 4668.
And then
Plus,
you would do plus 1.5, and then you would multiply that by the interquartile range, which was 3993.
okay. So that works out to be 10,567. Okay, so we've got our fences here. So one of them's negative, one of them's positive. That's interesting. So do we have any outliers? And I'm going to have Courtney, can you tell me if we have any outliers? Are you on mute, Courtney?
Sorry. Sorry, I couldn't get it off of mute. Is that if there's a 0, like if one of them has a 0, like nothing, no information on it?
No, so these are all of our collision claims right here. So they go from $180 to $21,000. So we're trying to determine if there are any outliers. So numbers. So you remember when we did the Michael Jordan salary thing, and Michael Jordan made $3 million a year, and everybody else made like $40,000 a year. And so Michael Jordan was way outside. I mean, that was kind of easy to see. What we're trying to do is we're trying to decide, are there any outliers here? Are there any numbers that are crazy?
It's probably like pretty gradual. I mean, like there's not one that's like.
Okay. So the way you're going to check that is you're going to look at your fences. Okay. We're going to say that anything beyond 10,567 is an outlier, and anything less than this negative number. Do we have any negative numbers in here? No. So we've got no lower outliers. Do we have anything greater than 10,567?
Yes.
Yes. And so yes, we do. Yes, we do have an outlier. And which one's the outlier?
It's 21,147.
Okay, so this is an outlier. I'm going to put that in a different color. Okay, so this is an outlier, and you can actually see it's twice as big as the 10,000, more than twice as big. So that shouldn't be too surprising. So this one's actually close to being an outlier, but it's within the fence. Okay. So yes, so basically we're comparing our fences to our data, and we're saying, is there anything fall outside of the fences? Anything beyond 10,500 is going to be an outlier, and so yes, that's an outlier. Okay, does that make sense?
Yes.
Okay. All right, so this is how we're going to find outliers. Now we need to create a box and whisker diagram. Okay, now you guys are going to have to do this on paper. One of the nice things about Excel, which you can't use on the test, is it has this little box and whisker maker. And you can see here, and I don't care if you do this horizontally or vertically, but the thing that I do want to point out here, a couple of things that you should do. Number one, you need to have a scale, okay? So we need to label our scale, and this will be cost of claim, and these are going to be 18 collision coverage claims. And I don't really need that or this, okay? So the idea here is, in fact, maybe I'll just go to here for a minute, okay? When we're talking about so this is a different data set here, but the idea here is each whisker, so this whisker here represents 25% of the data. This whisker here also represents 25% of the data. This would be an outlier. And then this box right here represents quartile 3. This line here represents the median. And then this represents quartile 1. Excuse me. This is quartile 1. This is quartile 2. This is quartile 3. And this is quartile 4. And in the case of an outlier, we're going to put a little dot or something outside here. Okay. So, the idea, these are two different box and whiskers, and I don't care if you do them horizontally or vertically. Probably on paper, it's easier to do it horizontally than vertically, but you can do it either way. It doesn't really matter to me. But so here's how I want you to do this. Maybe I'll just draw a generic thing here. So if I were drawing this, on paper, where's my, here we go, okay. So you can see as our data here would go from basically almost 0 to 21,000. So I'm probably gonna create my scale here. So the biggest problem I see on tests is people they make a box and whisker and they don't worry about the scale, but the scale is important, okay? So I'm gonna maybe I'll put little tick marks here. So 5,000, 10,000, 15,000, 20,000. Okay. So 5,000. And maybe I'll do it that way. I didn't make that scale very good. $15,000 and 20,000. Okay. I probably should move that line over. I'm going to erase that line because it looks like it's off. Put that about right there. Okay. So now the first point is going to be either, so we're going to either use either the minimum or the fence. Okay. Now in this case, it's going to be 180. So I'm going to just put a little thing right here. So that's going to represent 180. Okay. I don't have any outliers, so I'm going to use the minimum in this case. Because in the maximum, I do have an outlier, so I'm going to use this as my upper value here, okay? So I'm going to put a line at the minimum. I'm going to put a line at 735, which is approximately right here. I'm going to put another line at 1802. Oh, excuse me, I put that in the wrong place, didn't I? Because I wrote that wrong. This is supposed to be 5,000, and no wonder I messed that up. Okay. Okay, so I'm going to put a line here at approximately 735, another line at 1802, and then another line at 4668, which is going to be about right here. And then I'm going to draw a box around these three here. This represents the interquartile range here. Okay, so this box represents the interquartile range. I'll put a whisker from here to here. And then I need to put another whisker. Now, the other whisker is either going to be either the max or the fence. Okay. In this case, because the maximum is an outlier, I'm not going to draw it to 21,000. I'm only going to draw this to 10,500. Okay. So I'm going to draw a line from here till just about after 10,000. And then I need to represent this here as an outlier, which is 21,147. I'll just put a little circle here, which is about right here. Okay. So then I'm going to label this. This is going to be the cost of collision claims. Okay. So that's how you would create a box and whisker diagram. Okay. So it looks a lot better in Excel, but we can't use Excel. Okay. So do you guys have any questions about a box and whisker diagram? Do you feel confident you can create one, Brian? Okay. All right. So, all right. And then, so the nice thing that you can kind of do is you can also compare distributions. You can see in so if this is data set A, data set B, you can see that B is probably going to be a more skewed distribution because it has a much longer whisker than data set A, and it's also got an outlier there. So, all right. So, all right. Now, the last thing that we're going to cover in Chapter 2. So, just as a reminder, I probably should mention this. We're going to finish Chapter 2 today. We're going to have a review on Thursday. And then the following Tuesday, so 1 week from today, we're going to have our test, which is going to be chapters 8, 9, 10, 1, and 2. So it's going to be on 5 chapters. There we go. So, and I will post a review there. The last thing we're going to do today is we're going to do the hardest thing that's going to be on the test. I might save that data for another thing. but we're going to figure out standard. I hate this font on this one. Standard deviation. Okay. Standard deviation. I want you to think of it as the average distance from the mean. Okay. So let's pretend that I have a farm in Las Vegas and I have a farm in Idaho. And let's say that I buy 2 potatoes, and in Las Vegas, I get a potato that weighs 1 ounce, and I get a potato that weighs 9 ounces. In Idaho, I get a potato that weighs 4 ounces, a potato that weighs 6 ounces. And the first thing we can do is we can figure out the mean. So, Brian, can you tell me what is the mean size of a potato in Las Vegas? We're going to test that. Say it again.
Mean size of potato in Las Vegas would be 4.5.
How did you get 4.5?
I took, and I found the middle of 1 and 9.
So 1 plus 9 is 10.
Oh, that's 5, sorry.
Divided by 2 is?
5.
5. Okay. All right, and then the mean size potato in Idaho is what?
5.
Also 5. Okay. So it doesn't matter where you buy your potatoes. Who agrees with that? Right, go ahead and raise your hand, I guess. Courtney and Zach and Ellie, they don't care. Cody, who has a preference on where you buy your potatoes? Dylan, where do you buy your potatoes, Dylan?
Idaho is like the 4 and 6, right?
Right.
Yeah, Idaho.
So you like Idaho? Why?
Well, because the standard deviation's closer to the average, I guess. So you have like a better chance.
Most people, when you go to the store, you don't care about the standard deviation, right?
Well, yeah, I was just saying, like, for the math purpose, I guess. I was being like a brown user.
So I'm talking about real. You go to the grocery store, you get a bag, you buy 2 potatoes. One's labeled Las Vegas, one's labeled Idaho. Why would you prefer Idaho over Las Vegas?
Oh, well, if I saw like this size difference, I mean, you can kind of tell like when something looks like 1 pound compared to 4 pounds, maybe. So if you want.
Well, these are ounces, but yeah.
Ounces, yeah, but I don't know.
Okay, how about you, Mallory? You wanted the Idaho potatoes, right?
I thought we were just talking in math. If they have the same mean, then in the grocery store, I wouldn't care. But I thought we were talking about the standard deviation.
Well, we're leading into the standard deviation, but I'm trying to give a real world application here. So what about you, Clark?
So I raised my hand because different potatoes are going to have different like nutritional values depending on where they were. So not necessarily like applicable to the problem, but
the wrong answers today.
Potatoes in general.
Okay, Zach, you wanted the Las Vegas potatoes, right? Why did you want the Las Vegas potatoes?
I'm pretty sure my answer is going to be wrong, but it didn't. I think kind of the same as some of the others. It doesn't necessarily matter just because of the mean is the same for both potatoes, and you have a wider range of
so if
sizes
you're going to
Las
eat these
Vegas.
potatoes, okay, so here we're going to flip a coin and we're going to say, okay, Zach gets either the 1 or the 9 ounce potato, and then I get the other one. Are you going to want me to choose the Idaho potatoes or the Las Vegas potatoes?
Well, in that case, you'd want the Idaho potatoes.
Why?
They're how do I want to say this? I'd say the difference in size. Sorry, I'm struggling with words. The mean is the same for both of them, but with the Idaho potatoes, they're more close in size or weight than the Las Vegas, so
There
you have
we
a
go.
higher
That's
chance.
what I was going for. Okay.
Okay.
Okay. So I thought Zach was a gambler because he was like, well, I could get that 9-ounce potato. But now I see Zach as more a conservative guy, and he says, no, it's more fair to get the Idaho potatoes are more consistently sized. And I guess if we were going to eat the potatoes and I could get the 9-ounce and you get the 1-ounce, you're like, no, I'm going to go to Idaho, right? Because Idaho's more consistent. That's what I was going for. Okay. So you'll probably all agree that Idaho is more consistent. Is that true? Okay, that's what I was going for. Okay. So one way we could do this is we could do the range. Okay. Range, you could do max minus the minimum. On the test, so we could say that there is a range of 1 to 9 ounces here, which is a range of 8. Okay. We could also say that the range in Idaho is a range of 4 to 6 ounces, which is a range of 2. So we can see that Idaho is more consistent. Okay. Now, let's say that I add a third potato in the mix here. You can see, in fact, we'll make them both 5 ounces. Okay. Okay, so you can see that in Idaho, I've even made it more consistent with the 3 potatoes. Now they're only, instead of being 2 ounces apart, now they're only 1 ounce apart. Whereas in Las Vegas, I guess I've also made it consistent, but you can't really see any difference if we're only talking about the range, which is the maximum minus the minimum, okay? So range is a measure of dispersion, okay? You can think of this as a measure of dispersion, but you also know that this class is going to be way harder than figuring out just the range. You do need to know the range, okay? But we've got to do something more complicated in this class, right? This is a college class. We can't just be subtracting 2 numbers and saying that's it, right? Cody's laughing at me, but you agree, right? Okay. All right. So here's what we're going to do. I've got this great formula here, a couple of formulas here. Okay. So range is maximum minus minimum. Standard deviation is the square root of the variance. This is actually the variance right here. Okay. We're going to have, now you remember we talked about earlier the difference between a population and a sample. Okay. So remember, when we're doing our problems, we have to identify, am I dealing with a population or am I dealing with a sample? If I'm dealing with a population, I'm going to use this formula. If I'm dealing with a sample, I'm going to use this formula. Now, here's some other formulas that you're not going to use. You just won't use these, but you could do this too as well. This is the main formula I would like you guys to know. These 2 right here, population and sample. In both cases, you can think of these as the data. So x sub I in both cases represents the data. Then we're going to, mu is going to represent the population mean, okay? X bar is going to represent the sample mean, okay? So in both cases, it's going to be the data point minus the mean. We're going to square that difference. Then this thing here means we're going to add them up and we're going to divide it by the size of the population or the sample size minus 1, okay? So a lot of times, usually I do this, okay? Here, I'm going to add this to my notes. I can't believe, oh, that wasn't in my notes. Okay, so steps to find the standard deviation. Number 1, so here's what I'm going to say. On the test, I'm going to give you both this formula and this formula. In fact, it's on the formula sheet. I go back to, if I go back to the announcements, you'll see the formula sheet for tests and quizzes. So here's what I would recommend. You guys can go ahead and print out this formula sheet. And these are the formulas. I think it's a 1-page formula sheet. These are the formulas we're going to use on for the rest of the semester, okay? So I've got the population standard deviation here. I've got the sample standard deviation here. So I'm going to give you these formulas, and you can use those. I've also got the interquartile range here. You got your fences here. We've got a bunch of other formulas on here that we'll talk about later. I think those are it. So the main formulas you're going to need are these three right here and these two right here for this test. Now, just so you know, I've also got a random number table, a normal distribution table, anyway, all these other stuff. You won't need most of that, but you will need this first page. Okay. So, so I will give you the formula for both the population standard deviation and the sample standard deviation. Now, some of you like steps, and so I'm going to give you some steps. Okay. The first step is to find the mean of the data. Okay. The second, and this is true whether you're talking about the population or the sample. Okay. Second step is to find data minus the mean. Third step is you're going to square the difference. Fourth step is you're going to find the sum of the squares. Except for I can't spell squares. Fifth is you're going to divide by n or n minus 1, and it depends on population or sample. And 6 is take the square root. Okay. Now, by the way, I should also say this step is called variance. Now, you'll notice here on my sheet, I haven't put a square root on here. I have put it on here, though. There's a square root there. Okay. So sometimes we like to deal with the variance, and sometimes we like to deal with the standard deviation, but these are the 6 steps. So once again, I'll give you these formulas here. You don't have to memorize the formulas, but if you want to memorize these steps, you can memorize these steps. Okay. So
I have a question real quick on that.
Go ahead.
Just on the steps.
That must be Tori, because I can't see anybody else's lips moving.
It's actually me, Cody Lynn.
Oh, okay.
Sorry.
Cody, sorry.
My internet connection's a little slow, I guess, if you can't see me. I just had a question. When you say sum the, let me see, I wrote it down.
Some of the squares.
Yeah, find the sum of the
Yeah,
squares.
we're going to do an example right now, and I think it'll make a lot more sense. But go ahead and ask your question.
Well, I was just going to ask, like, if you take data point minus the mean and then square that, you only have one square, right?
Say that again.
So you're taking data point, which is like, maybe that's like 10 minus the mean, which could be 5, and you have 5 and square that, that's 25. So how are you finding the sum? Because you're not like adding that to anything.
Okay, so I'm gonna show you what I mean here in just a minute. Okay, let's pretend that we're on a new farm. Okay, we've got and this time we get 5 potatoes, and they're going to be 1, 2, 3, 4, and 5. I just want to keep this simple and easy. Okay. Now I also want to kind of understand that. So standard deviation you can think of as the average distance from the mean. Let's see here, Mallory Moore. Can you tell me what you think the mean is? I bet you can guess that without thinking too hard.
3.
3, very good. Okay.
And that's also going to be the median. I don't know if that's important.
It's also the median. The mean and the median are the same. We're going to be using mean for this, not the median. So let's talk about the distance from the mean. Okay. So what I'd like to do before we get all involved in these formulas, I just want to think about this logically. Okay. So Clark, No, let's go with Sam. Sam, what is the distance from 1 to 3? Are you on mute?
All right, I just said, wouldn't it be like 2 since it's 1, 2, and then you don't include the next
It would
one?
be 2. Okay, the distance from 2 to 3?
Oh, 2 to 3 would be 1.
3?
0.
4 to 3?
1.
5 to 3?
2.
2. Okay. Now I just want you to look at these numbers here for just a minute, and I don't want you to do any hard math. I want you to guess. What would you say if you were to guess what was the average distance from the mean between those 5 numbers? What would you guess?
Sorry, repeat that. I was writing a note.
So if you look at these 5 numbers right here, and what would you say the average is roughly?
About 1.5.
Yeah, 1.5. Okay. So that's so that would be our guess, right? And that's actually a really good guess, okay? So basically when we think of standard deviation, we're thinking of the average distance from the mean. If we look at these, we could guess about 1.5, because yeah, it's in between those 2 numbers, right? Okay. So that's actually a really good guess, and that's what I want to explain what the standard deviation is, okay? Now, as I said earlier, we're not going to do anything that easy. We've got to make it hard because it's a college class. And I'm going to try, hopefully, is that going to copy? Oh, it did. Okay. Cool. Okay, so this is the population variance. And we're going to do this one here. Okay. Now the question we have, wow, I'm so happy that copied. You never know when it copies and when it doesn't. Okay, so this is the sample variance. I don't know why that's so big. Okay, now in real life, you're probably going to use this formula here. I'll highlight this one in yellow. This is going to be more commonly used. More commonly used because typically we're going to deal more in samples than we are going to deal in populations. Okay. And so, but you do need to know both formulas, okay? Now, so here's what I'm going to do. I'm going to copy my data down here, and this time we're going to do it the real way, okay? So if you've got these steps written down here, okay, the first thing we're going to do, instead of guessing, we're going to find the mean, and so basically the mean is basically the sum of all of our data divided by 5, and just as, who did we say? It was Mallory that did that the first time, wasn't it? Just as Mallory said, the mean is 3. Okay, so step number 1, we found the mean. Okay. Step number 2 says we need to find the data minus the mean. Now, here's what I'm going to tell you guys on the test. I don't know how I'm going to do this on the quiz, but on the test, which is a week from today, I'm going to give you a data set, and I would like you guys, I won't give you a huge data set, but I would like you guys to label this so that I can follow what you're doing. And then if I can follow what you're doing, I'm going to give you more points, okay? So basically, you can think of this x sub I as these are your data points, and then you're going to subtract off your mean, okay? So in this case, I'm going to be more picky. When I did it with Sam before, we didn't worry about negative signs, but I'm going to worry about it this time, okay? So it's going to be 1 minus 3, okay? So step 2 is to find the data minus the mean, and we're going to do this. I think this answers Cody's question. We're going to do this for all 5 data points. So 1 minus 3 is negative 2. 2 minus 3 is negative 1, okay? 3 minus 3 is 0, 4 minus 3 is 1, 5 minus 3 is 2, okay? So does that make, so basically I've just done what's in the parentheses here. So any questions on what I've done so far? Okay. All right, now according to the order of operations, the next thing I'm going to do is I'm going to square the difference. Okay, so I'm going to take -2 and I'm going to square it, which is 4. I'm going to take 1, I'm going to square it, which is 2, or excuse me, which is 1. 0 squared is 0, 1 squared is 1, 2 squared is 4, okay? So I've just done the parentheses and this, and now whenever you see this weird looking E, it's actually the Greek letter sigma. Whenever you see this sigma, what it means is you're going to find the sum, okay? So I'm going to find the sum of all of these differences, okay? And the sum in this case is 10, okay? So I've just got the numerator, and in both cases, the numerator is basically the same, in whether I'm using the population or if I'm using the sample, okay? It's the data minus the mean, okay? Now, the question is, you need to divide by n or n minus 1, okay? Now, I'm going to divide by 5, which, because if I do this as a population, I'm going to divide by 5. I'm also going to divide by 4 if I assume that this is a sample. Now, in real life, I'm going to tell you, or you'll have to figure out whether there's a population or sample. I'm going to do this both ways just because I want to see how good my guess was. And you'll find out that my guess was really good, okay? In this case, I'm going to divide by 5. And so 2 is going to be your population variance. And in this case, I'm going to take 10 divided by 4, which is 2.5, okay? This is my sample variance. And then the last case is to take the square root, okay? So if I do the square root of 2, okay? Now remember that Sam had originally guessed 1.5. The square root of 2 is 1.41. So you can see Sam's guess was really close, okay? This is the population standard deviation. And if I do the same thing with the sample, square root of this, I'm going to get 1.58. And so this is going to be what we call the sample standard deviation. Okay? So you can see in both cases, these numbers are very close, okay, to our guess, which was 1.5. Okay, so does that make sense? Okay. All right. I think somebody put a comment here. What does the comment see? Oh, Brian said he was accidentally calculating the median from the mean. You do the top part of all the point. Let's see. You do the top part of all data points, correct? Are you talking about the fraction? Feel free to talk, Brian. It's faster to communicate. But if you can't talk, oh, okay. All right. Yeah, just feel free to interrupt me if you've got a question. But here's what I would like to do. Okay. We have a lot of data here. This is from one of the homework problems. And I'm going to say find the standard deviation for whatever this data represents. I don't even remember. It's a bunch of numbers, dollars and for something. Okay. So, do I have any volunteers that want to tell me how I won't make you do the whole thing, but you know, if you volunteer first, you get the easy questions. Or if you want to do the whole thing by yourself, you can do that too. So, because you're going to have to do this on the test. probably on the homework too, but for sure on the test. And if you don't volunteer, I'll pick on Clark. Okay.
I can do it
Clark,
if you
where do we
want.
start?
All right, so you find
Do
the
you want me
mean
to
of the
list the
data.
steps? Are the steps helpful to you or not?
Yes, that's what I'm using, so I think they're helpful.
Okay, so I'm going to copy the steps here. So I won't make you do the whole thing. We'll make you do step number 1. Okay. So if we've got my steps here, what's the first thing I need to do?
You got to find the mean of the data.
Okay. So find the mean of the data. So the mean is, how do you find that?
So you're going to add everything up together and then divide it by the number of entries.
Now, I'm really lucky because you're going to have to do this all on a calculator.
Yeah, I'm relieved you have it in the format you do.
Yeah. Okay, so how many pieces of data do I have? I've got 35 pieces of data, right? Because the first line doesn't count. Okay, so I'm going to take the sum of that. I'm going to divide by 35. And I've got my mean of 2801.65. Okay. Now I'm not going to worry about rounding. That's going to create a big problem for you guys, though. I would say when you're rounding, go to at least a minimum of 3 decimals. Okay, so what do we do next, Cody Lynn? Do you go with Cody or Cody Lynn, or do you care?
Call me Cody. It just says Cody Lynn on my name tag.
Okay.
Okay.
So what do we do next?
So you do data minus mean, right?
So data minus mean. So now you're going to see why it would be easier to do this in a spreadsheet, and you guys are going to have to do this in a thing here. So tell me what to do to this first one.
So you do equals 1725 minus the mean, right?
Right.
And then drag it all the way down because you're on
I'm
Excel.
going to treat, yeah, so you guys get to do this by hand. I promise I won't make you do 35 on the test. But yeah, I'll probably give you, 10 or something. Okay. All right. Step number 3 is what, Tori?
For this one, you square all of those numbers that you just calculated.
Square the difference. Okay. So how do I do this first one?
So you take negative 1083.6571 and square it. So multiply it by itself.
Okay. I'll multiply it by itself. And we did that lickety split. Okay. Step number 4 is what, Zach? Do you want to be Zachary or Zach, or you don't care?
I'll go by Zach.
Zach, okay.
So let's see, find the sum of the squares. So wouldn't we add them all up?
Okay, so we're going to do the sum of this whole column right here, which is a honking big number. Okay. And Dylan, what do we do next? Oh, actually, before we do that, Zach, this step has a special name. Oh, no, it doesn't. Next step has a special name. Dylan, I'll go to you. What is the next step?
You're gonna divide, but it depends on if you're using a population or the sample one, right?
Okay.
How much you're gonna divide by.
Okay, so if I told you this was a sample, what would you divide by?
To be honest, I don't know.
Okay, so we can look back at the formula.
35, right?
So the population is divided by n. The sample is divided by n minus 1. So if I say this is a sample, I'm going to divide by.
So n minus 1.
Minus 1. Now you're probably wondering why those are different, right? And the answer is it's very complicated reason, and you trust me, you don't want to take that class. But anyway, we'll just take it as there. Okay, so we're going to divide this. So we've got 35 in our data set, so we're going to divide this one by.
Sorry, 34.
34, perfect. Okay, this step has a special name, and the special name is?
Standard deviation, I don't know.
No, it's the step before that. Begins with a V.
A V, sample variable or variance.
Yep. So this is the variance, and because we said we're using a sample, it'll be the sample variance. Okay. The last step is what, Ellie?
Oh, you square root it, don't you?
Take the square root. So
Yeah.
the square root of this number here is $2,149.99. Okay. Since we're talking dollars, I'd probably change that to dollars. So $21.50. Okay. Wow, that was lucky. Okay. All right. So you guys gonna ace my test? That will be the hardest thing that you will do on this test. Okay. So
when are you going to put the review so we can kind of practice for it?
I will try maybe today, but probably tomorrow. I have more time tomorrow. So yeah, so I don't normally tell you what test questions are. I will tell you that there will definitely be a smaller data set, but you will have to find the standard deviation by hand. And if you can label it just like I did here, that will help me that will help you get more partial credit, so that yeah, anyway, so everybody needs to figure out the standard deviation by hand at least one time in their life. So here's your chance. Here's what I will say. Some of you probably have calculators that will Brian, that was funny. Oh, I totally lost my train of thought. Everybody's going to have to do this at least one time. Oh, I know what I was going to say. Some of you have statistical calculators that will figure out, you just enter the data and then you press it. I guess you can check your answer and see if it's right, but if that's all you do, if you just give me the answer 2150, you're not going to get any credit. Maybe 1 point if you're lucky, if I'm feeling generous. I want to see all the steps, and I want to see all these numbers. I won't make you do it on more than, say, 10, a data set of 10-ish. But everybody should at least have that opportunity. My statistics teacher was mean to me and made me do it, and I'm going to be mean to you and make you do it, okay? After this test, if you want to use that button, I would recommend that you do use that button. But for this test, you got to show me how to do it by hand, okay?
I have a question.
Go ahead.
So on the test, since we're doing it all by hand, how do we show you our work where it's all like through Proctorio and all that stuff? Like, how do we show our work? So
basically, I'll give you the data like this. And you basically, I want you to give me these columns. So, and I want to see these numbers. So you'll find your, oh, I forgot about this. You'll need to show me that too. Here, I'm going to move this over here. So you'll find your mean. So you write down your mean, and then if you want to, this is not a bad idea, actually. You could say subtract the mean. Whoops. And then you could say, I'm going to subtract 2808.657. Stuck an extra 0 in there. I didn't mean to. And then if you just copied that down, Then I could say, okay, so 17 minus 28 equals 1083. 4199 minus 28 is 1382. They square the difference, you get 117,000 or whatever that number is. Some of the squares. I want to see all these numbers, basically.
Okay, and is it just like a text entry box, like we just type it in?
Well, you're going to be writing it on paper.
And then do we just like show the camera, or?
Yeah, you're going to take a picture of your paper.
Oh, okay.
So yeah, so I guess we could start talking about the test now. So hopefully, I think I haven't checked, but I'm pretty sure everybody took the Proctorio test. The idea is, do I have a piece of paper here? Okay, pretend this is your test, or this is your paper. Obviously, yours won't be typed. Okay, so you'll just take a picture of your paper. Sorry, can't see here. And then you'll upload your paper to the, let me back up. Probably going to give you about an hour and a half for the test. So if you take it between the hours of 10 and 11:30, and then you'll have 30 minutes to upload the test. So you'll have 90 minutes to actually take the test. Between 10, so your test, then at 10:30 or sooner, if you get done sooner, take pictures of your test, put them in a Word document, and then you can either save it as a Word document or a PDF. I don't care, either one. Some students do use Cam Scanner. I think I've seen that, and that's fine. But you'll need to upload that as a separate file attachment. So basically, you'll have two assignments. You'll have the test, which will be a mix of multiple choice and show your work. If it's multiple choice, you can just answer it on there. I won't look at your paper. If it's show your work, like the standard deviation or the box and whisker or your stem plot or whatever that is, you'll just draw it on your paper, show all the calculations. You'll take a picture with your cell phone of your paper, and then, if it's 3 or 4 pages, just put them all in a single document, and then you'll upload that as a separate assignment. Then I will grade your paper, and yeah, that'll be that. So basically, your test needs to be completed by noon. It needs to be uploaded by noon. So you'll have 10 to 11:30 to take the test, and then it needs to be uploaded by noon. Does that make sense? Some people take pictures and then they upload like 5 attachments. It's better than nothing, but I would prefer if you just can paste it in a Word document or something. That would make my life a lot easier. So, because I'm going to have to be scrolling between screens, and grading tests is very hard when you're doing it on the computer. But anyway, so any questions you guys have for me? Okay. All right. So as far as Thursday, Chapter 2 homework is due. Chapter 2 quiz is due. It's going to be very hard for me to give you a test. I probably won't put standard deviation on the quiz, but I guarantee you it will be on the test. It will probably be the hardest problem on the test, and probably worth the most points. There will be some multiple choice. The multiple choice will be worth a lot less than the show your work problems. So, okay, well, we're done like 5 minutes early.
Quick question.
So, if you don't have any questions, I'll let you go.
I have a quick question for you, Richard.
You do have a quick question. Go ahead.
I got class at 11:30. Would I be able to open that up? Like, would you be able to open it up for me a little bit early so I could kind of have that hour and a half to?
Do you want me to open it up at 10:30?
Well, I have class at 11:30.
No, or sorry. So our class normally starts at 10. So do you want me to open up at 9:30?
If you could, that'd be great.
Okay.
Just so I have about the same amount of time as everyone else, that'd be great.
I'll do that. I'll open it up at 9:30. You'll have 90 minutes, so it needs to be done by 11 a.m. And then you have between 11 to 11:30 to upload your test.
Perfect.
Does that sound good?
Yep, that works. Thanks.
Okay. Any other questions? All righty then. Well, I will see you all on Thursday. Have fun. Thanks for coming.